Okay, so let's see, we're given that the radius of this loop is 0.075 meters, and the external field that the loop is immersed in is 3.5 Tesla. The resistance in the loop is 0.11 ohms. And then we're told that this loop basically starts on the plane of the page and then it flips around backwards by 180 degrees in 0.22 seconds. Okay, so delta t is 0.22 seconds, and yeah, it basically moves half a turn. I guess that's delta theta, if you would. Okay, so how are we going to do this? Well, we'll say that the induced EMF we'll use, it has a magnitude of n delta phi b over delta t, right? You know, n is 1, is it just a single turn loop? And for delta phi, well, what's happening is cosine theta is changing. So this is going to be BA times delta cosine theta over delta t. So we have the external B here. The area, pi r squared, is 0.01767 square meters using this radius. And then delta cosine theta, well, if we're turning 180 degrees, then delta cosine theta, you know, if we say that this is the initial area vector, so that theta is 0, then the final area vector would point out of the page, right? So cosine theta would change from 1 to -1. So the delta cosine theta term is actually 2. All right? And so the induced EMF then is going to be BA delta cosine theta over delta t, which is 0.56 volts. And so the induced current is going to be the induced EMF divided by the resistance, which is 5.1 amperes. I'm writing radius out and I'm writing resistance as RES just so we don't get those capital R's mixed up over here. How about the direction? Well, the change in flux is that it is into the page and decreasing, right? And what works for the first part of the motion, you know, for the first half of the motion will work for the second half, so it really doesn't matter how you look at it. So the number of x's as the circle turns such that, you know, maybe this top part comes out toward us and the bottom part goes away from us, the number of x's in the loop is going to get smaller. And so the induced magnetic field is going to point into the page to try to replace the ones that are being lost. So if the induced field points into the page, if that's the induced field, then the way you do that is by having a clockwise current going around here. Okay, so the induced current is 5.1 amps and it's in a clockwise direction.